Hello and good morning to everyone. This is Devasis Mohanty. Today in this video we will do the discussion on regarding the surface area and volume of the sphere. Actually everyone knows that the sphere having only one surface and that surface it is our curved surface. So for which there is no difference between the curved surface area and the total surface area. Curved surface area and a total surface area having the same meaning. So for which here I am writing to find out the curved surface area. To find out the curved surface area, it is also having the same meaning to find out the total surface area. As it has a single surface and that one it is our curved surface, for which curved surface area and the total surface area both are same. Everyone see, this one it is the structure of the sphere and this one it is the radius. Everyone see, this one it is the radius. To find out the total surface area, otherwise the curved surface area of the sphere, just like the last discussed solid, there we got the rectangular faces in cuboid. In cube it is our square face, and in the cylinder whenever I got it as the rectangular curved surface. Curved surface it becomes rectangular, but here whenever I will cut it from any of the side, here we will not get any of the regular known figure. So for which to find out the curved surface area, I have to use the thread. I have to use the thread, and by using that thread I have to cover the total surface. By using thread I have to round it in such a way. I have to round it in such a way so that the total surface of the sphere it is to be covered with the thread. Where I got that it is completely covered, so from that point I have to cut the thread. Then after, its radius it is how much? Everyone see, its radius it is how much? With that much radius, I have to make 4 circular patches. One circular patch, another circular patch, 2, here it is third circular patch, and here it is the fourth circular patch. See, with how much thread, the total surface of the sphere it was covered with the how much thread, the total surface of the sphere it was covered with that much thread. Whenever I am covering the surface of the spherical region, one surface covered, another one it is also covered, another one it is also covered, and also fourth one it is completely covered. So it means one thing it is clear, with how much thread the total curved surface area of the sphere it was covered, with that much thread thus 4 circular region having the same radius also it is covered. So it means one thing it is clear, that the curved surface area of the sphere it will be how much? It is also same as the area of the 4 circular region with that much radius. How much radius of the sphere it is at here? With that much radius, 4 circular patches it was covered by the same thread, for which the curved surface area of the sphere it is also same as the area of the 4 circular region. Area of the 4 circular region, and its area it is pi r square. Here I am writing its area it is our pi r square. Its area it is our pi r square. Its area it is our pi r square, and its area it is our pi r square. So for which the curved surface area it is also same as the sum of the area of 4 circular region having the same radius, for which curved surface area it is our 4 pi r square. Here at a time curved surface area and a total surface area both having the same meaning. Next we will do the discussion how to find out the volume. Everyone see how to find out the volume. And to find out the volume, this one it is our solid sphere. It is our solid sphere means within the sphere no empty space it is here. So for which we will do the discussion how to find out the volume of the material. Actually, volume of the material, it will be how much? See everyone, to measure the volume of this sphere, one of the experiment we have to conduct, and in that experiment we have to take one of the cylindrical bottle. It is one of the cylindrical bottle. Then after one of the sphere I have to take. Here it is one of the sphere. Suppose its radius it is R1. Here it is another sphere. Its radius it is R2. Here it is another sphere whose radius it is our R3. Here it is another sphere whose radius it is R4. And here it is the total cylindrical vessel. I am total filling with the water. Water it is filled up to the brim. Up to the brim, the water has been filled. Up to the brim. Then after one of this sphere I am putting inside it. Whenever one of the sphere I will put inside the cylindrical vessel, and the vessel has been filled with the water. 100% few of the water it is to be overflown. And how much water it has been overflown, that water I am collecting in one of the pot. So how much water it is overflowing, it is falling at here and it is being collected. And after collecting the water, how much water it has been overflown, it is 100%, it is same as the volume of the sphere. It is how much water has been overflown, also that much. So for which how much water it has been overflown, that water I am putting in one of the graduated cylindrical pan. Here it is graduated cylindrical pan. Here it is marked, here it is marked. So it means volume of the water, how much it is overflown, I can measure by using the pan. Then after the same experiment once again I have to conduct. Then after another sphere I have to put inside the cylindrical vessel. Once again the vessel has to be filled with the water completely. Also few of the water it is to be overflown. So it means volume of this sphere 100% it is to be same as the volume of the overflown water. Once again that water I collect and I put it at here. And finally it is seen one thing. So here the volume it is how much? It means whenever the overflown water I am putting it at here. It means it shows the volume it is how much by using our measurement pan. So by using this one I can find out the volume it is how much. Listen one thing, the volume of this one it is how much? It is also same as the overflown water. And overflown water it is how much? It is also same as, if I will write down the formula 4/3 pi r1 q. It means if I am calculating 4/3 pi, its radius it is how much, its q, how much I am getting the result, also the overflown water, its volume it is also that much. And whenever I am putting the another sphere of a radius R2, overflown water it is how much? It is also same as 4/3 pi R2 q. So it means this type of experiment whenever repeatedly I am conducting and I am getting it at always 4/3 pi radius its q. So for which the general formula I am writing, of the volume of the material, volume of the material in case of our solid sphere, it is our 4/3 pi r q. Understood or not understood? Next we will do the discussion of the sphere, where the sphere it is made up of a thin plate and inside one it is our empty one. Everyone see carefully. Previously the sphere it was taken, it was our solid sphere. It means no vacant, otherwise no empty space. It was there inside the sphere. The total sphere it is the solid one, completely filled with that material. And here it is one of the sphere. Everyone see where the surface it is the thin surface. Where the surface of this one it is the thin surface, just like this type of structure. Thin surface means width it is negligible, its width it is negligible. So it means I can fill this one by opening this one, otherwise by making the hole I can put anything inside it. Understood perfectly? And remember one thing, in the last few solids we did the discussion on regarding the made up of a thin plate, also thick plate. And whenever the thin plate regarding the discussion it was made, the upper surface area and inside surface area both are same. It was same. So for which here I am writing, whenever it is made up of a thin plate, you have to remember it has two surfaces. One it is our outer surface, and another one it is our inner surface. Outer surface and inner surface both having the same area. Whenever the thickness it is, whenever there is no thickness, otherwise the thickness it is negligible. Whenever the width of the plate it is negligible, it means outer surface and inner surface both are same. So for which here I am writing, one it is our outer, shortcutly writing outer, another one it is our inner. And here it is outer, its curved surface area. See, its curved surface area it is our 4 pi r square. Also inner, its curved surface area it is also same as 4 pi r square. It is the outer curved surface area, it is the inner curved surface area. Whenever I want to color, otherwise to do anything, outer also inner, it means total curved surface area it will be the sum of the outer curved surface area and inner curved surface area. Total surface area means total curved surface area. It is our 4 pi r square plus 4 pi r square, which is our 8 pi r square. It means outer curved surface area and inner curved surface area togetherly I can calculate it as our 8 pi r square. Whenever the outer regarding thing it will be asked means 4 pi r square. Thin plate, whenever it will be asked to find out the inner surface area, inner curved surface area, it is our 4 pi r square same. Outer curved surface area, inner curved surface area both are same. Whenever togetherly for both the things, outer work also inner work, it means total curved surface area it will be our 4 pi r square plus 4 pi r square, which will be our 8 pi r square. And here the volume is, previously it was completely filled with that material, no space it was there in that solid. That one it was our solid, but this one it is the empty one inside here. This one it is the vacant space. So for which the volume of this space, volume of this region, here the volume of this region it is also same as just like the previous one, 4 by 3 pi r cube. And next we will do the discussion whenever the sphere is made up of thick plate. Whenever the sphere it is made up of a thick plate, how to find out the curved surface area, also how to find out our volume also. Okay. See, whenever you are getting the sphere, where the sphere its plate having some thickness, otherwise the width of the plate is given. Width of the plate it is given, it means this one it is the width. Everyone see, this one it is the width of the sphere. So whenever you are getting the structure just like this having some width means it has two radius. One it is outer radius. Everyone see, this one it is the outer radius and this one it is our inner radius, which is our small r. One it is our outer radius, another one it is our inner radius. So in the same way, in the last case, the outer curved surface area and inner curved surface area both are same. But in this situation, outer curved surface area means outer area having a radius capital R, and inner curved surface area means area of radius small r. So here the outer surface area and inner surface area both will differ from one another because the radius varies. Here the radius varies. But in the previous one, whenever the plate it is made up of a thin plate, otherwise the width it is negligible. In that case, radius outer and inner radius both are same. So for which outer curved surface area and inner curved surface area both were same. Here outer curved surface area, here the radius it is capital R and here it is small r. For which remember, here I am writing 1, it is our outer, shortcutly out. Here I am writing inner. Outer curved surface area, it is our outer curved surface area. It is our 4 pi capital R square. And here it is inner curved surface area, it is our 4 pi small r square. And remember, suppose the small r it is not given and the width it is given. Width it is given. So it means from the capital R, whenever suppose the width it is x. Suppose whenever the width you are subtracting, you can find out the r. And remember, suppose you want to find out the width, you can find out the width by subtracting smaller radius means inner radius from outer radius. You can find out the width of the plate. It will be our how much. Here this one it is our curved surface area of the outer curved surface area. This one it is our inner curved surface area. If it will be asked for the total curved surface area, it is the sum of our inner curved surface area plus outer curved surface area. Inner curved surface area and outer curved surface area togetherly we are getting the total surface area, total curved surface area of the sphere where the width it is given. Okay, and another one it is our volume. Everyone see, here it is two types of volumes are found. Two types of volumes are found. Here it is one volume, volume of the inner space. Everyone see, here it is the volume of the inner space. Another one it is the volume of the material. Here it is the volume of the material. See, first one it is the volume of the inner. Everyone see, whenever having some thickness, it means one thing it is clearly seen. Outer one it is our sphere, also inner one it is also another sphere. Outer one sphere, here it is also inner one it is also another sphere. So to find out the volume of the inner sphere can be obtained by taking our inner radius. So for which volume of the inner, it will be our 4 by 3 pi small r cube. It means how much the water, otherwise liquid, otherwise any of the other substance you want to fill, it means 100% it can be filled in our inner region. So inner region means inner radius it is to be used. So for which 4 by 3 pi r cube. And remember, here it is the volume of the material. Volume of the material means, see, suppose it is the complete sphere. So from the complete sphere, if this much material I will take, if this much material I have taken, if this much material I will take this much material, how much material it will be kept? That material it is the volume of the width. So for which volume of the material can be obtained always by subtracting the volume of the inner sphere from the volume of the outer sphere. For which volume of the outer sphere it is our 4 by 3 pi capital R cube, and volume of the inner it is our 4 by 3 pi small r cube, and betterly you can write it as 4 by 3 pi within the bracket r cube minus r cube. Leaving this one. So in my next video we will do the discussion of the surface area and volume of the hemisphere. Thank you. Have a nice day.